Alright, sample problem 3.14 says that copper is obtained from copper 1 sulfide by roasting it in the presence of oxygen gas to form powdered copper 1 oxide and gaseous sulfur dioxide. How many moles of oxygen are required to roast 10 moles of copper 1 sulfide? So this is going to be a kind of a conversion problem like we've been working. So always the first step, remember, is to write down what we know. I know that I have 10.0 moles of copper 1 sulfide. So the first thing is to obviously figure out what the formula for copper 1 sulfide is. So copper, the elemental symbol is Cu, and by them telling me that Roman numeral 1, I know that that has a plus charge. Sulfide, that's sulfur. If I look on the periodic table and find sulfur, the closest noble gas to sulfur is argon, so it's going to have a -2 charge, right? It has to gain 2 electrons to get there. And anytime we're gaining electrons, that's a negative charge. And the common factor between 1 and 2 is 2, so that means I must have to have 2 of those copper plus 1 charges to go with every one of those sulfides with a -2 charge. All right, and then they're asking for how many moles of oxygen are required. So moles of oxygen equals question mark. So let's see. They've given me the moles of one thing, and they're asking me for the moles of something totally different, right? I've got the moles of copper sulfide, and they're asking for the moles of oxygen. This is a key indicator that my conversion factor, the only conversion factor I can use, is going to be the balanced chemical equation, right? Anytime you're given one thing and asked to find units of something else, you're always going to use the balanced chemical equation as the conversion factor. So that's our next step. Let's go ahead and write our balanced chemical equation. We have to identify our reactants first. It says copper is obtained from copper 1 sulfide by roasting it. So copper 1 sulfide is going to be my first reactant listed there. They're going to roast it in the presence of oxygen gas. So plus O2 to form. Now I'm going to write my yield arrow, right? That word form lets me know I'm now talking about products. Copper 1 oxide. So copper 1 still has a plus 1 charge. And I'm going to have 2 of them because oxygen oxide has a -2 charge. So I've got to have 2 of those plus 1 charges to counteract my -2 charge of the oxygen, plus gaseous sulfur dioxide. So plus, plus SO2, right? Sulfur dioxide. So now I've got to check to see if this thing is balanced. I've got 2 coppers on the left. I've got 2 coppers on the right. I've got 1 sulfur on the left. I've got 1 sulfur on the right. I've got 2 oxygens on the left. I've got 3 oxygens on the right. So my oxygens are not balancing out. So how can I turn 2 into 3? I just have to multiply that by 3 halves, right? Now I have to follow those rules for balancing chemical equations, right? The first one was to translate the statement. The second one was to balance the atoms. The third one is to adjust the coefficients if you have fractions, and we do. So I've got to get rid of that 3 halves. How am I going to do that? Multiply everything by 2. So I'm going to have, for my balanced equation, 2 copper sulfides plus 3 oxygens, right, because 3 halves times 2 is 3, yields 2 copper 1 oxides plus 2 sulfur dioxides. All right, so now that we have that balanced equation, let's start our converting. So I have 10.0 moles of copper 2 sulfide, and I'm going to set up my T. Now remember, if you checked out the Learn Smart and looked at the notes, these stoichiometric coefficients tell us the number of moles of each of these molecules in a balanced equation. So I have 2 moles of copper 2 sulfide, copper 1 sulfide. I got 3 moles of oxygen, 2 moles of copper oxide, 2 moles of sulfur dioxide. So if I want to go from moles of copper 1 sulfide, I need to look at my balanced equation and see how many moles I have. I have 2 moles of copper sulfide, right? And that has to go in the bottom because I have starting out with it in the top. And I'm wanting moles of oxygen, so I got to look at my moles of oxygen, and that's what's going to go in the top, because that's what I'm looking for. I've got 3 moles of oxygen. And now, let's see, I've got moles of copper sulfide canceling with moles of copper sulfide. Going to be left in moles of oxygen, which is what they're asking for. So let me do my math. I've got 10 times 3 divided by 2, which means I have 15 moles of oxygen. It's going to take 15 moles of oxygen to roast 10 moles of copper sulfide to answer that question, right?